Okay, morning everyone. Let's quickly go through this key assessment on basic organic and alkanes with a few alkenes thrown in, I have to say. Okay, question one. Quite a few of you got this wrong. Systematic name for this compound. You didn't recognise the chain of 6, I think. I'm not quite sure. If you had, you should be able to see that it is C, because there's a methyl group here on carbon 2 and there's a methyl group here on carbon 4. Question 2, this one, quite a lot of work really, I think, for 1 mark, but depending, I think if it was me, I would pass over this and come back to it, because you really need to look at the moles and then work out which one's got the same number of moles. It's a ratio of 1 to 1. So you add your chlorine to your alkene, any of these, and work out the moles. Okay, yeah, this one should have been easy to recognise because this is your standard formula or your general formula for an alkane, and of course alkanes don't have double bonds. I think most people got that right. And this one is the smallest molecule, yeah, so that's going to have the lowest boiling point. And then this one, obviously, in terms of the highest melting point, will be the one that has the largest surface contact, and that will be the straight chain, the one without any branches. Okay, so then we get on to the more extended questions. So you're given some information about some cyclo compounds. These are cyclo compounds, so they're not chain compounds, okay? Then you just ask for a definition, which a number of you missed out. You might have got the family of compounds with the same functional group, or you might have said that they had same chemical reactivity, which would have got you a mark as well, but you forgot to say that the difference between them is that they differ in chain length by CH2. Okay, question 7. Again, you give us some information here on some hydrocarbons, which they're all isomers of each other. You're asked for the empirical formula. If you don't know the definition, and obviously some of you don't because you just wrote the molecular formula, empirical formula, learn the definition, lowest whole number ratio of atoms in a compound. So you needed to divide by 2. Again, 2 definitions. What does saturated mean and what does hydrocarbon mean? And you need to say the only. Okay, so carbon-carbon single bonds only in a saturated compound. Hydrogen and carbon atoms only in a hydrocarbon. Skeletal formula. Some of you didn't draw the skeletal formula. Again, read the question. Make sure you're doing what you're asked to do. General formula, some of you gave the general formula for an alkane, which of course is not correct, because if it's a cycloalkane, you've lost the 2 hydrogens from either end of the chain. So you haven't got the CH3 on the end that you would normally have. So you've got 2 hydrogens less than in an aliphatic alkane. And then explain the increase in boiling points. This is going to be the fact that you've got more carbons, more electrons, bigger molecules. Yeah, so you need to somehow reference that, which leads to stronger London forces. And then finally, you must say that more energy is required to break them apart. Okay. Yeah, learn your shapes, bond angles. You know, some of you got this wrong again. Shouldn't really be getting these kind of things wrong because this is just learning stuff, and you should be learning it by now. Your exam is too close for you not to be revising at this point. Okay, and the explanation is always for, you know, why do they take up the shape? It's always because the bonding pairs repel equally, or, you know, if there is a lone pair, the lone pair repels that bit more. So, you know, whatever the shape is, you look at what is around the central atom and they all repel equally, or if it's a lone pair, they repel a little bit more. Okay, Yeah, I don't know why this can cause confusion. A lot of you got this right, but a number of you got it wrong. It's asking you to prepare cyclohexane, which is this one, from hexane. So they give you the formula for cyclohexane. You should be able to write the formula for hexane and recognise that if you're forming the cyclo compound from a chain or an aliphatic compound, you're going to end up with 2 hydrogens left over. Right, okay. Oh, I think, yeah, I must have scanned that page twice. Sorry about that. Let's ignore that one. Okay. Right. Draw and explain the shape of an ethene molecule and state the bond angle in ethene. Well, ethene, some of you put the extra hydrogens in here. Obviously, the formula is C2H4 because it's got a double bond. It's planar, trigonal planar, and the bond angle is 120 degrees. Draw and explain the shape because the 3 bonds around the central atom are all repelling equally. Bear in mind, I mean, this is not part of the answer, I've just written this, that the multiple bonds are treated as single bonds when we're looking at shapes. So it's just treated as 3 bonds, 1, 2, 3. You wouldn't need to put that in your answer. Okay, yeah, complete combustion, pretty straightforward. That shouldn't cause any problems. And I think there might have been a bit of confusion here with this one. This bond angle, they're talking about this bond angle between the carbons and the hydrogens here. And this one, they're talking about this bond angle. Okay, definition, unsaturated hydrocarbon. Obviously, this is the opposite to saturated. It contains multiple bonds, either double or triple. That should actually say between carbons, yeah? And then hydrocarbon, we know what that is. Again, you're asked to write an equation using molecular formula. Okay, so not structural formula, which is unusual. So, but do what you're asked to do for the formation of dichlorobutane from butane. So you're adding in chlorine to butane, but you've got your side product of HCl, so you need to have enough chlorine, so you have to balance the chlorines, yeah, which a number of you didn't do. Right, yeah, complete this table, pretty straightforward. Draw the displayed formula of 1,4-dichlorobutane, and I think everyone got that right. Some of you got this wrong though, I don't know why. I think some of you numbered it 2 and 4. It's always the lowest number combination. So 1 and 3 is the number combination. You're counting from this end, 1, 2, 3, 4, not this end, 1, 2, 3, 4. Okay. Reaction between, right, okay, so radical substitution. So definition of homolytic fission. Some of you didn't say that, first of all, that it is the breaking of a covalent bond. That's crucial. That's what we're talking about when we're talking about the fission bit. And then the electrons are shared equally between the atoms to form 2 radicals. So you're breaking the covalent bond to form 2 radicals, yeah? Know the definition, please. And then you're asked to write these missing species in the propagation step. Now, just because they didn't put a dot in, this is obviously a radical. If it's chlorine atom on its own, it's a radical. I've put the dots in just to remind you. In the mark scheme, you didn't have to put dots in, but I would always personally put dots in to remind myself where the radicals were. So you're forming a radical here by the chlorine taking a hydrogen. Yeah, so you've got HCl here, and you've formed your butyl radical, well, chlorobutyl radical. And then, of course, this radical then goes on to attack a chlorine molecule again, and you end up with your chlorine radical. So what you're doing, you should, if it's a propagation step of this mechanism, you should always be producing 2 radicals. And you've got the chlorine radical here and chlorine radical here on opposite sides of the equation. And here you've got your chlorobutyl radical and your chlorobutyl radical on opposite sides of the equation. That's what you're looking for when you're writing propagation steps, to make sure that you've got them right. Okay. you're asked here for an equation for incomplete combustion. Now you could have given either of those equations, producing carbon monoxide or producing carbon soot. Okay. Yeah, so bond angle A and bond angle B, there did seem to be a bit of confusion with some of you as to which angle was being talked about up here. Yeah, this is referring, it's obviously not referring to this one because this one is, if that makes sense. So I understand that it maybe doesn't, it's not as clear as you think, but use your common sense really. So in the carbon chain where there are single bonds, it's tetrahedral, as all carbon compounds are, four bonds, single bonds, and the bond angle is 109.5, and in around the double bond it's trigonal planar and 120 degrees. And this one, I mean, really, anyone who didn't draw this diagram needs to, I don't know, go and stand on their head or something. I mean, we went over this, we've done this to death in the class to draw this diagram to represent the formation of a double bond. Yeah, so it's a sideways overlap of p orbitals. Explain with the aid of a sketch, which some of you didn't do, how p orbitals are involved in the formation of the CC bond. Here are your p orbitals and you're showing sideways overlap, and then you're forming the pi bond. That's all you need to get the 2 marks. Okay, all right, this one, yeah, well, most of you I think got this right actually. Working out the water of crystallization. So basically you're given information on the hydrated, how much hydrated zinc sulfate there is and how much there was left after you've driven off the water. So if you take 2.46 away from 4.38, that tells you how much water there was in the compound. So now you can work out your moles of the anhydrous and water. So number of moles, find the ratio, it's 1 to 7. Okay. I mean, this, you know, I mean, we did it quite a while ago, but you would have an example of it in your blue book, and you should just go through this whole sequence. Yeah, you work out your moles, you divide by the lowest number to find the ratio. It's exactly the same way as you would find an empirical formula. Okay, and then we're going on, you're given some information about a reaction, zinc oxide and hydrochloric acid. Yeah, so you're told a number of moles of zinc oxide, and you're given a concentration and a volume for the acid. So you can work out the number of moles of hydrochloric acid, and you recognise that you need to have twice as many moles of the hydrochloric acid than the zinc oxide. So you need to find out which one is limiting. Yeah. So to get twice, you need at least 0.16 moles. If you multiply that by 2, yeah, you need 0.16 moles of zinc oxide for that to react. When you work out how many moles of acid you've only got 0.12. So that is your limiting reagent. So the one that is limiting is the one that you use in your calculations. You don't use this number of moles, you're using this number of moles, 0.12 moles. And then it's pretty straightforward to find out how much zinc chloride you could produce. The ratio of zinc chloride to hydrochloric acid is 2 to 1, or I've put here 1 to 2. For every 1 mole of zinc chloride, you need 2 moles of hydrochloric acid, so we just divide our number of moles of hydrochloric acid by 2 to find out how many moles, and then we just convert that to mass. Okay, 8.18 grams. So, you know, going back to mole equations, you can't get away from them, I'm afraid, when you're doing chemistry, and you need to have them at your fingertips. And then there's another final part here you're asked to work out as a percentage purity. So you're told that you have an impure sample of zinc powder. Now some of you use this value to work out the moles of zinc, but you can't because this is impure. and you don't know how much of that 5.68 grams is the impurity. Yeah, so you need to use something else. There must be some more information in the question to enable you to answer this question. Okay, so what have we got? We're told that you produced a mass of 10.7 grams of zinc chloride. Now, that zinc chloride, it's a 1-to-1 ratio here, isn't it? You've got 1 mole of zinc in your zinc chloride. So if you work out how many moles of zinc chloride you've got, which is easy, that would also tell you how many moles of zinc you've got. Yeah, if that makes sense. Because this is impure, this zinc, but this zinc is reacted now with the chlorine and formed zinc chloride, so this must be pure. And it's because you've got 1 mole of zinc for every 1 mole of zinc chloride, the mass relates to the moles of zinc as well as the moles of zinc chloride. Okay, I hope I've explained that well enough for those of you who didn't get this right. Some of you did get it right, so you're obviously on the right wavelength. Okay, so we've got our moles of zinc chloride. We'll give you, yeah, it tells you there. Okay, right, so work out our moles of zinc chloride, which is this value. Yeah, we can convert that now to a mass. Yeah, so once we've worked out the mass of pure zinc, 5.13, we can now easily find the percentage purity, because we just divide by the impure mass of zinc into the pure mass of zinc times 100 gives us 90.3. Yeah, some of you got a bit confused here, and obviously this question is written in a way to confuse you, because it makes it look as if it's a cyclic somehow, because it kind of looks like a sphere, but it isn't, of course. It's just a chain of 3, whether you count across 1, 2, 3, or whether you count down 1, 2, 3. And on the second carbon, you've got 2 methyl groups. Now you can either say 2,2-dimethyl propane, that's fine, or you could just say dimethyl propane, because it can't be anything else. Because if you put those methyl groups anywhere else, you would extend the length of the chain. But that's fine, which either of those answers would do. And you're told about the boiling point, and you're asked to explain why the boiling point of this is lower than the straight chain isomer, and that obviously comes down to the branch chain has less surface contact with another molecule. London forces are weaker, and therefore less energy required to break them. Okay, and then we've got this compound produced when X reacts with chlorine. So here we've got dichloro. Yeah, we've got 2 chlorines on here, haven't we? Deduce how many other position isomers of Y can be formed. So really you need to scribble them out, I think, if you can't see it, and it's difficult to see. So you're talking about taking this CH3 group and moving it. Yeah. So yeah, you can stick it over here, and which will make the chain longer. Yeah. So if you draw them out, you can't put it anywhere else. If you bring it down here, it's exactly the same molecule. If you stick it on that end of the chain, it's the same molecule. So there are actually only 2 isomers of this, which means there's only 1 other position isomer. Yeah. Position isomer means obviously that you're taking this group, this dichloromethyl group, and exchanging it with a hydrogen somewhere. Yeah. And then again, this seemed to cause some confusion. Correct name for the alkene monomer. Alright, so you've got to recognise obviously what the monomer is. So you're putting your double bond in here. Yeah. And then so just draw it out. You know, your CH3, CH3, C double bond. Put your double bond first. Stick the bits that are attached to the chain, and then count up the chain. 1, 2, 3, 4, 5. Yeah. So there's a methyl group here. You've got your double bond. So the double bond is on carbon number 2, and so is the methyl group. And then, is there, I don't know, another couple of questions. Yeah, which statement about ethene is correct? So really, I mean, you just got to go through them all, and you know, if you know your alkenes, you know that there is no free rotation around the CC bond, so we can discard that one. It does not react by nucleophilic addition. It has to be electrophilic because it's the double bond that is attractive. So it's the an electrophile, something that likes electrons, that is attacking this molecule. So not nucleophilic. It burns in excess oxygen. Well, yeah, it does. So you should know that, and then just check that this is also false, which it is. It's not twice as strong as the CC bond, because as you know, they are not equivalent. Okay, and the pi bond is weaker. Right, and then the last question, again, it was a naming question, and I think if you didn't draw it out, it's difficult to see. To be fair, there's a typo here. It wasn't CH3. But again, I don't know, really, at this stage, you should know that it can't be CH. There's no way you could have a CH on its own. So you should be able to recognise that there is a 3 missing there. But I'll give you that, the fact that it wasn't there. That could have caused you some confusion. But if you just draw it out, you can see there's a chain of 6, this double bond is on carbon number 3, whichever way you count your chain. And you've got 3 methyl groups, 1, 2, 3. And whichever way you count the chain, they're on carbons 2, 3, and 4. Okay, so that's it. So yeah, I think in general the test wasn't done too badly, but some of the basic stuff, you just need to learn off by heart to make sure you pick up all those marks that you can. See you soon. Bye.